Alright, good afternoon. Okay, today we'll proceed with the second half of the chapter where we are talking about another type of graph known as the speed time graph. Okay, now if you compare our distance time and the speed time graph, it looks almost the same. The only difference here is the axis itself. Okay, so for speed time, your vertical axis determines, or vertical axis is actually the speed, whereas your horizontal axis will actually be the time. Okay, so when you look at the graph, looks similar, but our interpretation on this graph is slightly different. So now if you look at the movement of a particle from O to A, we realize that here the speed is actually increasing from O, is going up to A, right? And from A to B, as you like what we've seen before, A and B, looks like the speed is actually the same, right? So if you're talking about this part, so let's say we integrate from O. At O, the particle starts to move, so the speed is actually increasing here. This is 10, 20, 30, 40, 50, up to 60. Now, meaning there's a change in speed. Okay, all right, so speed is actually increasing. When it comes to A, the particle is actually moving with the same speed, or constant or uniform speed. So it's 60 all the way up to B. Once it reaches point B, what happens? The particle actually lessens its speed. So it's actually lessening. You see, initially from 60, now we come down to 30, okay, 20, 10, and finally 0. So what they're trying to show is from the graph, here the particle starts to move, reaches A. From A to B, it's actually moving at a constant speed. And from B to C, it actually gradually lessens the speed until it stops at point C. Okay, all right. So now, a few things you can actually interpret from the graph. Okay, when we are talking about OA, for OA here, okay, what we can actually see is, okay, from O to A, the speed is actually increasing. Okay, so you can actually see the speed is increasing from O to A. All right. Okay, now when you're talking in terms of a gradient of the line OA, so the gradient is actually the change in speed from O to A over the time taken. So if you've noticed this formula where you have the change of speed over time taken, now this can be denoted as acceleration. All right, so that means for this part OA, what happens is my acceleration is actually positive. Why? Because when you look for the gradient is actually positive. Okay, the slope, okay, you get positive. Okay, that's one. Okay, now when we're talking about this part here, AB, okay, when you're talking about AB, what happens in AB? My speed remains the same. We call it the uniform speed. Okay, and another thing is when you're talking about gradient, gradient here, there's no gradient. So meaning gradient is 0. So when gradient is 0, what happens? There is no change in speed, means there is no acceleration for this part. Okay, and then when we are talking about from B to C, okay, what happens? From B to C, the speed is actually decreasing in speed. Now the gradient is actually change in speed over time taken. So now the acceleration, if you notice, when you look for the gradient for this line, it actually be a negative. Okay, the gradient is going to be negative. So therefore, my acceleration is also negative, meaning the speed is actually decreasing little by little. Okay, now another thing that you can actually look at from the graph is, let's say we are looking for area below the graph. So if you notice, OA, this line, if I actually draw a line down here, this part here actually becomes a triangle. So this is my part A, or area of A. A to B, we draw two lines. Now this becomes a rectangle. So this is area below line AB. And from B to C, actually draw a line down. This is actually a right angle triangle. So this is actually area below the line BC. Okay, now this is a special feature for a speed time graph. We're actually looking for area below lines. Okay, line OA, area is A. Now this area is actually denotes the distance traveled by a particle from point A to point B. Okay, likewise, area below the line AB, area B is actually the same as or is equivalent to the distance traveled by this particle from point A to point B. And likewise, from B to C, we are looking for the area below the line. So C here represents the distance traveled by the particle from point B to point C. Alright? Okay, now for A to B, from O to A, if you're talking about area, we're talking about the area. Area is actually a triangle, so area is actually half base times height. So your base is actually time and your height is actually speed. So if you notice this part here, speed multiplied by time is actually distance. So that is how we got this definition. So area below the graph is actually representing the distance traveled by the particle. Okay, likewise here from A to B. A to B is actually a rectangle. So same thing here. So area below the line AB, right, is actually area of a rectangle. This is half length times breadth. So same thing, length here is actually your time and speed. Speed is your width or your breadth. So this again denotes the distance. Okay, likewise for BC, same thing. This is actually an area for triangle C. So you're talking about area below the graph or the line BC. So area of a triangle is actually half base times height. So this is again time multiplied by speed. So it actually represents area below the graph. Okay, so these are two special features that you can actually get from a speed time graph. Number one is the gradient of the graph will represent the acceleration, and number two, the area below the line, okay, actually represents the distance of the graph. Okay, so what you can actually do is, okay, after watching this, all right, so can you please try these questions first? Okay, so this is self-practice 7.2a, number 1a and number 2a, and self-practice 7.2b, number 1, 2, and 3. Thank you.